Will the new telescope detect aliens in space? News of the James Webb Space Telescope is still at the forefront of science and technology news just weeks after its launch, during which time many people around the world follow the launch, gradual opening, and deployment of space. Now all parts of the James Webb Space Telescope are scheduled to disassemble, and gradually over the next few months, we will have to wait for the first James Webb observation data to be sent. Much has been said and written about the technical specifications and information about the equipment embedded in the James Webb, but what has received little attention may be the question of what the James Webb Space Telescope is basically supposed to observe, and how it is supposed to do so. Before answering this question, it should be noted that the James Webb Telescope is primarily based on the detection of infrared waves. In fact, different telescopes each reveal a part of the universe that is not visible to other telescopes. With X-rays, gamma rays, ultraviolet light, or radio waves, we see things that cannot be seen with visible light, that is, with optical telescopes. The data from each of these telescopes is valuable to cosmologists and astronomers in many ways. The Hubble Space Telescope, for example, observed visible light, ultraviolet light, and some infrared waves, but the James Webb Space Telescope sees parts of the universe that cover a much larger spectrum of infrared. Now the question that arises is, what information about the universe do infrared waves give us, and what is the use of looking at the universe with infrared glasses? Infrared Army, the precious legacy of Gary Nugebayer. Scientists have realized for decades the importance of detecting infrared waves in the depths of the universe, but few have probably heard of Gary Nugebayer, an American scientist, born in Göttingen, Germany. Nugebayer, who died about 8 years ago, was one of the pioneers of infrared astronomy, which has played a major role in the observation of this part of the universe since the 1960s. Projects such as the 2-Micron Sky Survey, TMSS, revolutionized infrared astronomy and dramatically increased our knowledge of the universe. Historically, the ideological basis for the construction and launch of the James Webb Space Telescope is rooted in the evolution of infrared astronomy during the 1960s and 1970s. In other words, in the research of a team of researchers at the time, the Infrared Army were called. What is the importance of seeing the infrared spectrum? The fact is that some objects in the universe are so-called cold, and do not emit much visible light or energy. Visible light waves often encounter obstacles in their path such as dense nebulae and massive clouds and dust, and are therefore invisible to us. One of the things that infrared detection telescopes like the James Webb do is actually allow us to look inside dense clouds and see what is going on behind these dense nebulae and dust. The problem is that brown dwarfs or precursor formation stages are barely visible deep in a nebula. Hence, James Webb reveals hidden parts of the universe to us that are not visible at all. Another function of the infrared telescope, such as the James Webb Space Telescope, is to observe the infancy of the universe. The galaxies formed give scientists access. This is because our universe is expanding, and hence visible light, or even the ultraviolet rays of distant stars, are shifted to longer infrared wavelengths due to a phenomenon called redshift. Therefore, the detection of this part of the electromagnetic wave, the infrared spectrum, can give us a lot of information about the nature of dark matter, dark energy, black holes, and the evolution of galaxies. The equipment installed on the James Webb receives sections of the infrared spectrum called near-infrared and mid-infrared, which can be used to see things that Hubble could not observe. Although the Hubble Space Telescope also observed parts of the infrared spectrum, by comparison, Hubble could see objects created only about 400 million years after the Big Bang, but James Webb could go even further and use equipment. Infrared detection observes a universe that is only about 100 million years old. No one still knows exactly how the universe evolved from a simple state of just hydrogen and helium to a complex one today. One might ask, if James Webb is one step behind Hubble and can unravel the mysteries of the 100-million-year-old universe, how far can that go, and can a telescope be built in the future that helps not just children or are you a baby of the world, but observe the moment of the birth of the world? The answer to this question is unfortunately no. Because between us and the Big Bang, there is a wall of plasma that does not allow us to go beyond 380,000 years ago and see the light of the primitive and newborn world that is only a few thousand years old, or even the moment the universe came into being. Thank you for watching the video. If you like the video, send it to your friends, and subscribe to us. To improve the videos, please share your comments with us. We love you.